Hello and welcome back to my C++ tutorial playlist. And in this video, we will take a look at how to debug our applications effectively. This will only be the start, and we will mostly focus on GDB in this video. We will make use of some of the more involved techniques in the following projects more and more. But of course, I also want to show you the other techniques that are available, and I will also present them very shortly here. Our usual pipeline is that we first of all want to enable all the compiler flags and all the warnings that we have, and then also all the sanitizers, and we will also want to use Valgrind from time to time to get some overview of our memory usage and if there are some misallocations that we haven't freed or if there are some other artifacts. Then after that, we also want to run that automatically from time to time is clang-tidy and cpp-check. These are static analyzers that will do a static code analysis, and we can often integrate that into our IDE or editor to get some code insights there. Also, what we can use dynamically, if there's a bug in some memory allocation or some of a library function or anything, we can also start the application with strace and ltrace to take a look at the system calls with strace and ltrace for the library functions. So we can often spot if there are some invalid arguments passed there. Also, printf debugging is still an option. I put this here explicitly because it's often disregarded, or some people say you should never use printf when you have a real debugger and so on and so forth, but this can often be the quickest way to find a bug. Just print out the information that you want and yeah, be done with it basically. Also, make heavy use of assertions in your code so you can be sure that the code executes as you expect. And the great thing about assertions is that they won't be built in a release mode, so they won't affect you there. Also, you can use static asserts to check things that you can check for at compile time also. So these are also a favorite of mine to use, so use them everywhere basically. And another thing, of course, is custom tooling and logging libraries. We will use this in our following projects a lot, but for now, I just wanted to hint at that here. We will take a closer look in the following videos, how this tooling might look like and how it will help us to analyze our application further. Of course, some IDEs also have some more or less well-integrated debuggers. Some IDEs like Visual Studio are really good at that. Also, CLion has a really good also CMake debugger, so that's really helpful there. But for some IDEs, it's a little bit lacking. So with that, let's jump into a practical application and take a look at how we can use these techniques, and especially GDB and lldb. I will also show really quickly to find some bugs and in our application and see what it is doing under the hood. So now that we are back in the terminal, I have searched around a little bit for an example project that we could take a look at, and I thought about, let's take a look at my video editor that I use to edit these videos. So first of all, I want to point something out here in our CMake presets. I only have one preset here because I only built it for myself. And in here, it's really important that we want to export our compile commands, because all of our static analysis done with clang-tidy and cpp-check will use the compile commands JSON that this exports, and this will then be in our build directory. As we can see here, we already have one, and that is the compile commands JSON. What we can do now here is to start static analysis. Let's take a look at clang-tidy first. And here we want to specify p and then the path to our build directory. And here we can see all the analysis that will be done. Enable checks, as you can see, a lot of stuff, and that usually takes a while. So no reports here, so far so good. Usually If you have a bigger project, then a lot will come back, but that's all right. You just need to work through it, and you can also disable some checks. And another static analysis tool is, of course, cpp-check. And there you want to specify also the compile commands JSON, and that will also run a lot of checks. And as we can see here, we need to enable that, do an exhaustive check, and also nothing came back here, so we are good so far. So what we can do then, to help us with dynamic testing, we can analyze sanitizers, and these will basically crash our application if they detect invalid memory access, if we have address sanitizer enabled, or if we hit undefined behavior. There's also a sanitizer called ubsun. What we can enable here is make exx flags, and here we need to give this switch sanitize. These are the usual ones I use. I think there's also, and we also need to pass that as the linker flags. So exe linker flags, we also need to pass the fsanitize, and then the sanitizers we want to enable, but we don't need the rest of that. Also, we don't need the rest of that here. And this is for the shared linker flags, like that. And with that, we can reconfigure our binary with cmake reset default. And of course, we have a spelling mistake here. Sanitize, also sanitize here and sanitize here. So let's try that again. And of course, we don't want limit, we want memory leak sanitizer here. Sorry about that. So let's run this again. Now our video editor has been built, has been reconfigured. Now we can build it with the sanitizers enabled. And important here is that we either have debug or release with debug info. Release with debug info is a little bit faster. And in here we can see I have an input file that we can cut using the video editor as an example. So just as you can see, it's a regular video. And then we can run the video editor. And when we run it, usually it takes in the input MP3 automatically and then does its thing. Now with the sanitizers enabled, so if we hit anything unexpected, then it will prompt us. I won't let this run through right here now. Oh yeah, maybe let's wait. Maybe we can find something. I will just let this finish for a second. So once that is done, we can see our application hasn't crashed. So the sanitizers didn't detect anything, and that's a good sign. And here we can now see there's not only an input MP4, but also an output. And when we open that, output, then we can see it has been edited. So that's great. But now we can finally get into some dynamic debugging. So let's get into some debugging with GDB. And first of all, then let's open GDB and then enter the application that we want to debug, which is the video editor in our case. And as we can see here, I'm using Jeff, and you can easily install Jeff yourself. If you take a look at this GitHub, it's very simple to install. As you can see, we can just run any of these and use Jeff then directly. And you can also set it up persistently. Just follow the setup guide GitHub page, Jeff. And first of all, we want to set a breakpoint somewhere where we want to break, and usually we want to just set a breakpoint then at the very start here, and then we can run our application, and then we can see that we have a breakpoint right at the very beginning of main. And from here we can see which line executes here and so on and so forth. And we have a lot of information here about everything that's going on in our application. So if we want to take a single step, we can do SI. And if we want to go to the next instruction, we can write next or just N. And if we just hit enter, then we will go line by line. And as we can see, it's everything that we execute right now is just before we actually do anything. So let's go here. And so on and so forth. We can also, if we have some variables here, we can also make a watch on them, create a watch on them, and then they will be pinned and we can keep track of their changes. So let's say we want to, there's no real good example that we can use right now. That's a little bit unfortunate. We could also take a look at how we got here when we entered backtrace. Then we can see that we have been called from main, and that's it. That's our entire call stack right now. And we can also create a display. As we can see here, we have now a display of our inhale intervals, and then we can see all of the detected ones. And this is always the start and the end. We can also take a look at our breakpoints that we have set with info breakpoints. We can see that we have only one breakpoint and one watch point, and that checks whenever. So breakpoints hit when we enter execution there, and a watch point is when we modify this variable, then it will get triggered. We can also delete breakpoints. When we say delete 2, then our watch point will be deleted, and when we say delete 1, then our hardware watch point will be deleted. If we say list, then we will get a view of our current function as source code, so that's also pretty useful. And there are some interesting functions that Jeff offers us. Usually they are mostly for exploit development. If you're interested in that, you can take a look at my other playlist. But for us, mostly the configuration is probably interesting, where we can modify how Jeff looks and what information we get, as we can see here. And of course, we can also call functions. When we say info functions, then we should get a list of all the functions. And of course, that is a lot. That's really a lot. But if we want to, for example, don't want to navigate our application to a certain point, we can also just skip to the execution by using call. And then we need to specify the type of our function. Let's say we have a void return type, then we would specify it like this and then call it like that. But yeah, we don't want to do that here. Let's say we want to list something. Let's see what functions we have here. We have a lot, but let's say we want to list print line. Then we can see all the definitions of print line here. And we can see when we continue, then we still have two displays. And when we want to don't show this every time we want to continue, then we can also undisplay them on display. And then we just provide the index just as with the delete. And what else can we do? When we want to take a look at one feature of Jeff is also that we can have a really cool hex dump. For example, when we want to take a look at some strings that might be on the stack, then we can write hex dump and then the length is byte, and then the RSP is for the stack pointer. Then we can take a look here. And with clear or just delete, you can delete all breakpoints. And when we say quit, we can quit out of here, but we don't want to do that right now. One really cool thing is the terminal user interface, and we can open that with Control X and A like that. Then we have maybe a little bit friendlier user interface where we can scroll here through our code and enter commands down here where we have our instruction pointer highlighted. And yeah, so let's say we want to go to next instruction, then we can follow our application and what it does and still have our Jeff interface down here and have a better overview of the code at the top. So we have taken a quick look at GDB and how to use breakpoints and how to navigate the binary a little bit and how to use watch points. And also we had a quick look at the TUI interface that doesn't work that great for me. So let's have a really quick look into lldb also. And you started basically the same, just lldb and then the application you want to debug. For lldb, it's important that the binary you've built has been actually built with Clang to get useful information out of it. And then in here, you can just enter help to get a list of all the commands that are available to you. And let's say we want to just, here we can also list main again. And we can also set breakpoints in lldb. We can set B, and then let's say we want to break here. Just enter the line number, and then we can run the application. So now for debugging, I wrote a very simple program with some bugs in it and some very bad practices. And when we try to run this, then we can see it outputted 0. And the first thing I want to show you is how Valgrind will show you what went wrong. And for that we need to compile it, and we need to provide the source code here and then the output. Then we will have a debug me binary, and if we run Valgrind on it, then it will give us a detailed description of everything, and we can look through it and especially look here in the leak summary. And when we can see here that the heap usage, we have 5 allocations and only 1 free, and still that many bytes allocated. Let's rerun it with leak check full. We can also see where uninitialized values can come from when we specify track origins, yes. And we can see here an uninitialized value was created by a heap allocation. And here we can see that an uninitialized value has been used. And where has it been used? It has been used and here by our output stream operator. So as you can see, Valgrind can show you a lot of information about the memory that has been used, where it comes from, and also if uninitialized values have been used, and so on. And what we want to do next is to jump into GDB and step through this program step by step. And for that, let's compile it again and specify the G flag. And the G flag includes debugging information into the binary. And as we can see here, we start right into Jeff. And what we can do here is to jump into the terminal interface with lay next. And then here we can see the assembly instructions. And if we press enter again, we can see the source code as well as the assembly instructions. And that is really helpful. So we can see that we are here in main. So let's hit break main. And then when we press N or we press R to run the program, then we can see that we have stopped right at the beginning of main. And with N again, we can step to the next instruction. So unfortunately, the TUI is a little bit messy with my terminal emulator, but we can still do the same stuff. We again break at main and run and press N so we can, so Jeff already shows us everything here that happens, and we can again print the array variable or even array at 2, and that's still 0, so let's hit next. Then let's print out the value here again, and we can see it is 1. And here we want to output array at 3, so let's say we take a look here, and of course it's 0. So when we continue here, we can see, okay, we throw here, and we can see that we got a SIG abort because of the unhandled exception. And that is already what we wanted to see here. So let's say we take that out of there and compile this again. And we'll start, it automatically stops at the first instruction that is here in the start function. But ideally we want to break in main because before that it's only the program startup and nothing interesting for us. If we enter list, we can see the function that we are currently executing. So let's say we want to continue. Reason breakpoint. We still want to continue. Continuing. And now the process has exited normally. So far so good. Let's see what Valgrind tells us. So now the allocations and the freeze match up, as we can see here. And all the blocks are freed and no leaks are possible. This is what we want to see. So let's see again when we track the origins, because there's still a use of an uninitialized value that should be detected here also. Uninitialized value created. And here is the use of the uninitialized value, so we can see that in the Valgrind output. And if we track that down, we can definitely see that an integer to char conversion happens, and that happens for the output stream buffer, and that calls here the put. And the origin of that whole stack trace is here the main function at line 7. So let's see what we did wrong in line 7. Here in line 7, okay, and we can see here we have a conversion from an integer, so that has to be this. And we can see here, yes, we have only initialized 2, so probably we meant to write 2 here. So now back in Valgrind, let's see what it detects now. Still have something like this. conditional jump or move depends on uninitialized value. Of course, we need to recompile. So now what does Valgrind say? And now Valgrind is happy. We have no more reports here, and also the allocations and freeze match up, and no leaks are possible, so that is what we want to see here. Of course, in a real application, we would never allocate such a small array on the heap, and also this is an old C-style array. We would rather use std array of int if we want to allocate it on the stack, or of course use a vector if we want to allocate it on the heap. But that's just an aside. I think I've shown you all the basics on how to use GDB and some other tools to debug your applications. This was just a very first glance at how to go about it. If you want to learn more about how to use GDB, there is a really great course on pwn.college. I will link that in the description also, where you can learn GDB and debugging in more detail. Also, there is a small cheat sheet on my website that will also be linked in the description. And if you want to have more practical examples, there are more videos coming up with actual projects that I want to cover, where we will use all the tools I have shown you in this video in a practical way. And of course, there is nothing better than to practice and research yourself, because that really sticks if you made the experience yourself. So thank you very much for watching again, and see you in the next video.